Welcome to my portfolio critique. So a little bit about me. I'm a creative technologies major with a business administration minor. I was also a lab assistant for about 2 years, and this past summer I actually worked as a summer lab assistant. And for the past 10 months now, I've actually been working as an engineering intern with a company here in Rome called Wiretech Ltd. My theme today will be creating innovative tools and processes to increase workplace efficiency. So I think the 4 projects that I have that really encapsulate this idea are my automated removal system for 3D printing, my Hello Drybox, which actually stores actual filament over time, my Parameterized Designer, which is a Fusion 360 fixture editor, and my fuse spotter, which is also my capstone, which is designed to detect incorrectly placed fuses through computer vision. The first one I want to touch on is my automated print removal. So when actually doing my senior exit hackathon, I really wanted something that was related to 3D printing. So kind of went around my printer and wrote down every single actual aspect of making a print. So when it came to actually loading the filament, taking the filament out, and actually turning each and every knob to get a print going. But by far the most time-consuming one was actually removing the print. So I really wanted to find a way to actually automate this. So I looked up a few little methods. I saw on Reddit that using G-code, someone had actually automated cleaning their nozzle. And I was like, well, I'm not going to add a motor on here to clean a nozzle, but I think I can actually use the print head. So what I ended up doing was actually altering the G-code within Cura to give the print head an automatic removal system, and then we get another. So you can kind of see within here, this is my actual printer. You can kind of see on here that I actually designed to do housing for the print head. That actually gives it a little bumper. You can see it better in the next slide. But within here, I adjusted the NG code. So it actually goes to the back of the print bed and actually just thrust forward to actually take the print off. And also I have it loop back into the start of the G code. So it just actually keeps repeating itself. And here's a quick and dirty video for that. It should play automatically. Unable to play video. Sweet. Well, what the video would show you is you can kind of see right here. I have this little bumper that actually is on the end of the print or end of the print head. So when this print is done, it actually goes up, goes right straight back, and then thrusts forward to remove the print, and then it begins another one. This would be pretty beneficial, you can see, for like some small scale manufacturing utilities, but there is a kind of gray area where if the print's too big, you can actually impact your printer and in a negative way. So it's a little bit finicky in some points, but I did find the best way to actually do this is with really small base prints that don't have much adhesion and without painter's tape or anything like that, and just on an actual clear bed. I do have the bed before it actually knocks it off cooling down to about 20 degrees, so it kind of lessens the adhesion a little bit. But for my testing, I've done it about maybe 40 or 50 times, and it didn't impact my printer at all. But in terms of small scale manufacturing, I think this is a really good tool that can be utilized. Next one I will be discussing is my Hello Drybox. So to understand why this came about and why I actually created this project, it was my first month at Wiretech, and I really just wanted to play around with some new types of printing. So we had a lot of TPU and nylon, and I really wanted to get into nylon printing. So when I went to actually print this nylon, it looked horrible and it started bumbling up everywhere. And I was really concerned with, why was it doing this? And I realized that we had this filament out for about a year, and this filament was hygroscopic. So over time, it actually absorbed water. So when you went to print it out of a really hot nozzle, it boiled that water and made your prints really bubbly. So I wanted to find a way to actually stop this so we can actually store these filaments over time. So what I came up with is my Hello Drybox. So you can kind of see over here, there's a few 3D printed elements that were printed outside of the hackathon, but these were made inside of the Fusion environment to actually hold PVC, which then holds the actual filaments. Down here, we have a temperature control module, which actually communicates to the heating elements. And you see the humidity sensor right here. So when it actually gets above a certain humidity, this heating element actually kicks on and actually lessens the humidity a little bit. This has natural PID tuning in it to actually kind of settle any loop problem that we have. So let's say if it was at if we were looking for it to aim for 50 degrees and it went to 51 and it went back to 50, just to stop that loop from going back and forth and kicking back on and off. But as you can see, this is made to actually, increase the longevity of filament in general. Another really cool aspect of it that I really enjoy is I added a valve and tube extension to the top. So you can actually still use these filaments while they're inside the box and keep it temperature controlled. But in this case, I haven't plugged up just because I'm not using them. So stepping into more of stuff I've done for my internship, my next one will be my Parameterized Designer. So when introducing this issue, it's important to realize what these guys are. So these are fixtures. These fixtures are made for testing wire harnesses. So there will be actual little pins in here, little metal connectors that actually will connect to testers. And then when you plug in harnesses, it'll actually test the continuity of them. One of my first big tasks at my internship was figuring out a way to actually make one of these in quickly, because we were missing this one right here, and we needed to get a board into production. So I was tasked with actually finding a way to make this work. So I said, let me see if I can actually 3D print one. When I went to print one, it was a huge success and it actually worked. So in my brain, I thought, let's see if we can automate this a little more to get all these manufactured in-house. So I created a whole system that you can actually go in and change a single digit on here, and it'll alter to give you the desired fixture. So every single base width, base length, and actual pin is connected. When you change like 2 or 3 numbers, and it'll actually give you the desired fixture, and you can print it. And the reason this is so significant is simply because one of these fixtures right here, these fixtures are standardized for each one, or for each connector. So this is for an actual terminal strip. So it's a pretty specialized connector. So they're very expensive. So each one is about $800 a piece. And you can see with actually printing them in-house, we cut that down to about 4 cents a piece. So we now do this for mainly these fixtures just because they're so expensive and specialized. But you can see that genuine margin right there is very significant. And the last one I wanted to discuss is by Capstone. And this one has a lot of information, so I apologize for throwing it all at you, but to really understand this issue, you kind of need to know a little bit more about wire tech and how the process works. So this right here is a board for production. So what I actually do is I design these boards based off blueprints, and then give our operators kind of signifiers that let them know what they should be actually creating. So the issue we had arise are these fuse boxes right here. So you can imagine if you have a single human all day working on this board right here and looking at this image on how to place these, and that is our only way of checking. You can see how over time you're going to have some incorrect fuses. And I think our parts per million of these are about 2,000 incorrect ones per million, which is a really drastic number that needs to be reduced. And it is by far our most rejected harness by our biggest customer, which is, an ugly standpoint for us with them. So we really want to attack this and figure out a way to do it. So what was the way of doing this? I thought the solution was to create a whole system that integrates with Dynalab harness testers to automatically check the placement of the fuses. So in the short term of kind of explaining it, you can see right here, these are all the iterations that I went through of actually creating the housing. So these housings will actually go on boards that you just saw in the last one, and the fuse boxes will be placed inside of here. The reason it's closed off is there's actually a camera mounted at the top of here with a LED and a diffusion panel right above it to kind of disperse light a little bit. But this allows for some image processing to actually create a region of interest over every fuse, and then actually do some optical character recognition to basically compare to the targets that we want. So you can see down here, I kind of have a few UI images that kind of guide operators through the process of what they should be doing. And this will all be actually mounted. Can't really see it in this image, but back here through a touchscreen Pi that will also be mounted on board. So through the whole system, you kind of can see what it's doing right here, but we have a Raspberry Pi that is kind of set off by this right here. So this is the housing with a button in the back. So when it's pressed in, it'll actually start the code. This code will immediately run through the Pi. And if the Pi says these are correct, it'll relay that back to the control port module. The control port module will then tell the tester. So another big thing, so you got to see right here is the image processing. It actually creates a region of interest over every fuse, and then does that OCR detection. But another big thing is for quality assurance, I have it taking an image and dropping it off in a server. So we can actually attach this to any of our harnesses, send it out to our customers, and just say, hey, we did what we were supposed to do. Here's our proof. And I'm guessing my video isn't going to work. But the video that I had on here was just showing the whole process. It's still a pretty low fidelity prototype. And the reason for that being is I accidentally fried my Pi last week. So this is supposed to be in production this week, but sadly it's running on a 3B plus. And the video, if you could see it, it would take about 13 seconds to run the whole system, but with a brand new Pi, with Pi 4, it runs in about 3 or 4 seconds. So it's a drastic cycle time change for when operators are actually doing this on a daily basis. But in terms of how many harnesses this will actually touch in a year, according to the numbers we had based off last year, this will be touched around 28,000 harnesses in a year, which is our largest output for harnesses and going to our largest customer, which is a pretty big thing for us. This may be cheating. Well, this video would basically show you.
Keep talking.
This video would basically show you the whole process of it. It is a working system currently. All we're waiting for right now is just that final Pi to actually put it into production. But
It's impressed. Yeah.
I got you.
Viruses. I can't download.
All right, keep going.
yeah, but that basically show you the whole process of it. It is a working system right now, and it's pretty reliable so far. I ran, I think, about 50 tests on it the other day, just in recession, and it worked. I think it was like 45 times out of the 50. The biggest issues that it runs into is basically sometimes you'll get a little bit of kind of noisy images just because light isn't diffusing properly. So that's the biggest issue right now. But I think over time, once I get it on board and actually get to test it a little more, I'll be able to kind of hone in that system. But in terms of what's next for me, I have signed with the company WireTech. I've been working with them for about 10 months now, as stated. But I've signed with them 2 weeks ago as a manufacturing engineer. That position title may change a little bit depending on when I'm working full time and what I will be doing on a daily basis. But I'm pretty excited for that, and it's been a huge journey so far, and I'm just glad I got to share some of these projects with y'all today. And I appreciate y'all. Questions from the panel?